Okay, that's recording now. So welcome. I'm going to share my screen and show you some slides that I put together. There we go. So you should be able to see the presentation now. And making sure I can see the chat. There we go. Okay, so we've got two things. We've got the online test that's tomorrow, and we've got the exam in January. And what I've done is I've taken all of the bits of information that have been communicated to you, and I've just put them together into this presentation. I'm going to talk through it. There's loads of text. I just copied and pasted stuff from emails and things. There's loads of text. What I'll do is I'll put this presentation on Blackboard so that you can just make sure you can see all of the instructions there. And I'm just going to highlight the key points as we go through. And feel free to ask questions in the chat on the Zoom call. And there's lots of instructions because this is different from what we've ever done before. These types of, certainly the open book exam at home, we've not done before. So there's lots of points about how to try and make that work and the right way of doing it. Okay. So tomorrow we've got the last thing for this part of the semester, which is our online test. This is going to be open from between 3 o'clock and 3:30 tomorrow. And it's going to have 10 questions. Each is worth 2 marks. So it's out of 20 in total. And that's worth 20% of the module. You can start the test between 3 and 3:30. So you need to start it within that half-hour window. And you'll have 60 minutes to complete it. It's open book, so you can look at your notes and other stuff, but you have to do it on your own. Don't try and do it with anybody else. It's going to be a mix of multiple choice and numerical answer questions. There's no negative marking, which you'll probably like. However, you will only see one question at a time, and once you've answered a question, you can't go back to previous questions. So you only have one chance to answer the question. And we do that. I know you probably won't like that way of doing it because it means you can't go back and check answers and so on. But this is to make the test more robust and to make it more difficult for anybody who wants to do collusion or anything like that. Makes it more difficult. It's a more robust assessment, so that means it's fairer for everyone. So now you can't skip a question and go back to it. You have to decide what your answer is there and then proceed with it. I appreciate you won't like that probably, but it's the same for everyone. So you just need to take your time and make sure you're confident with your answer before you progress. And it makes it fairer for everyone because it really helps to cut down on anyone who tries to do it in a group. Okay, so just looking at the chat questions. No, you can't skip ahead and go back. If you're unsure, you have to make your mind up there and then. Do the questions get harder as you go through the test? No, they don't. The questions are randomized, so each student gets the questions in a random order, and they'll be mixed up by topic, and they'll be mixed up all together, and the questions are all about the same hardness. Are they lengthy questions? I wouldn't have say so. They are obviously these questions. You should be able to do them within 6 minutes per question. As opposed to an exam question where you're expected to be able to do it in about 30 minutes. So they're quite short questions. They're testing your knowledge of the course and your ability to do the basic parts of the course, but there isn't in-depth calculation required really for any of them. You cannot go over if you've made any mistakes. No, you have to make sure that you're confident with your answer before you progress to the next question. Will the questions be the same intensity as the tutorial questions? Well, the tutorial questions are vary in difficulty and depth, so I can't really answer that. They will be more like the simpler tutorial questions. Most of the tutorial questions, where there are lots and lots of them for the first 3 weeks of my ones at least, they start easier and then get more harder. They will be like the easier ones. Is it half stats, half calculus? Yes, it's 50-50 between my stuff and Dr. Abdul's stuff. Will we be given distribution data if we had like a stats question? yeah, you would have, I mean, it's an open book exam, so you can go onto the internet, you can look at your notes and all of that, and the questions will, we expect you to be able to do it pretty quickly, so the questions will give you the basic stuff that you need so that you can crack on with it. Is it from all the material we went through? Yes, it's covering the whole semester. What the question will look like, could you give us some example, please? No, I'm not going to give you some examples. They are, you know, like short questions based on stuff in the semester. Is it possible to get partial marks for a question? We've designed it so that it's right or wrong, so you get 0 marks or 2 marks. That's the basic setup. Some questions may have a partial mark, but at the moment I don't think that's the case. Okay, that's all the questions on that, so I'm going to move on. Yeah, and we'll try and get the marks released by Friday if all goes well. Okay, here's the maths exam. This is a picture of you after your revision session. There was an email sent to you on the 2nd of December, and that contained loads of information about your exams. And that's what I've been through. I've gone through that and I've just edited it to make it relevant for our maths exam. But I wanted to make sure you have all that information and you know where it is. So what will your exams look like? They will be assessed with a 1-hour examination with 2 questions, which should take about 30 minutes each. They are open book exams, so you can look at the internet, you can look at your notes, you can look at textbooks, but you have to do it on your own. Don't try and work with anybody else to do it. Each day you have an exam. The exam window will be opened at 9 AM on that weekday in the exam's timetable. Questions will be similar in style and format to past exam papers, so you can use the past exam papers to do your preparation. The main difference will be that whereas some past exam papers ask you to do a derivation or ask sort of basic things like that, because these are open book exams, we won't be asking that, because obviously you can just search it on Google and copy your answer in. So they will be a bit different from that. There'll be more emphasis on the application of your knowledge and less on the direct recall of material. The exam for maths will cover all of the material in the lectures that Dr. Abdul and I have done. The exams will be released through our Blackboard page, and then you submit it likewise through Turnitin on our Blackboard page. How do you do your answers? Well, it's up to you. You can type them or you can write them on pen and paper. But basically, at the end of the exam period, you have to produce a PDF of your answers, and then you upload that PDF to via Turnitin. And it has to be a single PDF file. So you can do it however you want, but it needs to be a single PDF file. So if I was doing it, I would, just get the question sheet, the exam paper, and I'd just use pen and paper and work through it on a piece of paper and then take photos. There's a link here that's available through the email, which is a way to create a PDF using your smartphone and taking pictures. And we appreciate that will take some time. So the exam window is longer than that. So the exam should take 60 minutes of your work, but we're giving you an extra hour on top of that. So then you have 15 minutes to get sorted out, to download it and so on. And then 45 minutes to upload your answers. So, so essentially you've got 2 hours for the exam in total, and you have to do all the work within that, but you also have to give yourself time to get your material ready to upload. After that, there's a 1 hour late penalty zone. So you can upload your work up to 1 hour late, but then there will be some penalties involved in that. But at the end of the 1 hour penalty zone, you can't submit your work. So you have to submit it within that time period. Obviously, don't leave it to the last moment to try and submit it, because then you might have a problem. The 45 minutes is there to give you the time to sort out any problems that might come about. So we won't be very sympathetic if you say, oh, well, I couldn't upload it at the last minute because of X, Y, or Z problems. We've given you the time to do that. So you have to give yourself enough time to make sure that you can upload it satisfactorily. So it's advised that you submit as soon as you've finished rather than waiting to the last minute of the submission window. The email didn't actually mention this, but when we set the exam up, we are able to give you the option to submit more than one version. And so I've not seen guidance about that. I think it I'm not sure if there's guidance on that, but I'll look out for that. I would presume that you can only submit one piece of work, so I'll take that as your assumption. Okay, so this is what it looks like time-wise. The exam will be open at 9 o'clock, 15 minutes to do it. Try and finish the exam by 10:15, and then you've got until 11 to do your final submission. And then from 12 till and then from 11 till 12, you've got the time if you have a late submission, and then it closes at 12 and you can't do it after that. So I'm told that you should have, the email said you should have your exam timetable already. I've not seen it myself, but it said that you should have it. It will be within the 2 weeks, the 18th to the 19th of January. I don't know what day it is yet, but they say that you've been told. The university is not giving you personalized exam timetables this time due to the complexity of all the changes. So it's your responsibility to check the timetable and make sure that all your units are there. I don't think any of you will have anything outside of CS, but if you did, that would be your responsibility. CS will provide year group timetables for ease of checking. If you're a DAS student, then the extra time allowances will be built into your submission portals, so that should be taken account of for you individually. So for example, if you had extra time, you would get 25% of the additional allotted 1 hour to do the exam. So that would give you an extra 15 minutes for the whole time period. So instead of having a total of 2 hours, you'd have a total of 2 hours, 15 minutes, and so on. If you need help with that, you can contact the disability support service. What if something goes wrong in the exam? So obviously, if your answers are going wrong, then that's your responsibility to deal with that. But if there are technical problems, or if you have questions that you believe that there is something wrong with the exam question, or you think something's missing, then you can contact us via the Blackboard discussion forum. So there will be a page there where you can put your questions in, and we will be monitoring that through the exam and respond there for anything that comes up. So you've got a direct line to Dr. Abdul and myself during the exam in case you think there's a technical a problem with the paper. IT issues we can't really help with, but you have a email that you can use here, or a phone number that you can use to try and tackle any problems promptly that come up. If you have a problem with your submission, if something's gone wrong and it's just not working, that shouldn't happen, but as a backup, what you need to do is take a screenshot of what's happened and email that straight away to the ESO-CS email address to get the evidence of what you have. And you should also email your answers in before the end of the time window as well. So as long as you send your answers by email to that email address before the end of the time period, then we will sort that out and that will count as your submitted work. So you won't have a penalty. But if it goes wrong and you don't submit your answers until after the time window closes, then you'd have a problem, because that wouldn't be accepted. So whatever happens, make sure you submit your answers, if not through Blackboard, by emailing the ESO. And then the very last problem, if there's a technical fault with the university software, so if Blackboard fails or something like that, then the university will have to deal with that, and they will let you know time for a replacement exam. That's unlikely to happen, but just in case something like that does happen. So good luck to you, and from myself and Dr. Abdul. I'm going to just take a look at the chat questions that have come up and see if we can help on those. Okay, will we be told how many significant figures to use? Well, if you are told how many to use, then you have to use that many. If you're not told how many to use, as I've emphasized in the lectures, it's your responsibility to use a sensible number of significant figures. Often 3 is a sensible number, but in the lecture course, which includes accuracy and precision of answers, I emphasized in the lectures that the number of significant figures that you show in an answer, it's indicative. The reader can take that as indicative of how accurate your answer is. So if you're giving more precision than is reasonable given the actual accuracy of the number that you're reporting, then that's a misleading thing to do, and it's not good engineering practice. So don't do that. So if you're not told how many to use, then spare a moment just to think, well, how accurate is this likely to be? And then you can give an answer which is relatively proportional to that. 3 or 4 significant figures is normally ample in the sort of work that we do. Can we write on a tablet like an iPad and then send working to the PDF? Yeah, you can do that. So long as you can produce your final working into a single PDF file and upload that, then you can do it however you want to. For the exam, can we scan our work? Yes, you can. You can write it on paper and scan it or take a photo of it. Again, you have to be able to produce that into a PDF. So it'd be a good idea to, whatever method you think you want to use, it'd be a good idea to practice it before an exam and just make sure that you are able to produce a PDF without any problems. Okay, that looks like all the questions. So I'm going to hand over to Dr. Abdul now, who's going to do the next part with some of his questions, and then I will return afterwards to go through a couple of questions. Thank you.
Okay, hello everyone. As Dr. Peter said, I will show you some examples from the past exam. Actually, this is our journey in just 1 second. In calculus. We started with differentiation, and we talked about the concept of differentiation and also some applications of differentiation. Then we talked about numerical solutions. We focused on actually solver and also Newton method, the Newton-Raphson method. Then in our journey, we went to multivariable functions. We focused on partial differentiation and also some application of partial differentiation. And finally, we finished with integration, the concept of integration, and also integration techniques. So we'll start with this equation. This equation was in 2019, 5 marks. Calculate the limit for limit x approach 0, 1 plus 2x to the power 1 over sine x. Actually, the first thing we need to substitute here 0. So we'll get here limit 1 plus 0, it will be 1. 1 over 0, it is infinity. So when you have 1 over 1 to the power infinity, this means we should think about a Hopital rule. But we cannot apply Hopital rule for this example because we need a fraction. So when you see like this equation, the trick here to actually to apply natural logarithm for both sides, and then this power will go down. So in this case, I will assume this function y equal to 1 plus 2x 1 to the power sine x. So I want now to take a logarithm for both sides. Len y equals 1 over sine x times 1 plus 2x. So in this case, I want to find the limit for len y. Be careful for this one, len y, when x approach 0. And this will equal to limit 1 over sine x times 1 plus 2x. I want to take the limit for all of these when x approach 0. So in this case, I can apply Hopital rule. the differentiation of the denominator and the differentiation of the numerator. The differentiation of the numerator, and here the differentiation of the denominator.
I'm sorry,
So,
doctor. Isn't it ln 1 plus 2x over sine x?
1 plus 2x, yes, over sine x.
It's ln 1 plus 2x over sine x.
Yes, correct, yes, correct. Len, and here we need to take the differentiation for both of them, and this will be limit x approach 0, and len 1 plus 1 2x, the differentiation will be 2 over 1 plus 2x over cosine x. So I take the differentiation for the denominator and the numerator, and then I will substitute here 0, 2 over 1, this is 2 over 1, this equals 2. But this one for len y, this answer for len y, and so we need limit y when x approaches 0, this will equal 2 e to the power 2, because this one len y. So this is the final answer. So the trick in this equation, just you need to take the natural logarithm for both sides, and then you will have the fraction, then you will apply Hopital rule. This 5 marks. So don't be panic if you find similar to this equation. Just take natural logarithm for both sides. Now we'll move to the other question here. This one in 2018. And this question was for Taylor series. Find the 3 non-zero terms of Taylor series for the function sine by x centered at a equal to 0.5. Use your answer to find an approximate value to sine pi over 2 plus pi over 10. So we need here to apply the Taylor series. I will write the Taylor here series to remind you. Fx equals to n equal 0 till infinity. We take the differentiation of the function over n factorial, of course, centered at a, times x minus a to the power n. So we need to take the differentiation, the first differentiation, then the second differentiation, third differentiation centered at a. So our function is fx equal to sine by x. So the first differentiation f prime x equal by cosine by x. And then the second one, f prime prime. So this question 4 marks here. F prime prime equals to minus p squared sine by x. And then the third one, x minus pi cubed cosine by x. And the first one equal to pi to the power 4 sine by x. Now we need to substitute in this equation. So this means sine by x will equal, it is centered at 0.5, centered at 0.5. So sine here, sine by over 2. I will write it here, sine by over 2 plus minus pi squared over 2 factorials times x minus half to the power 2 plus to the power 4 factorial times x minus half to the power 4. And we'll continue like that. We'll get the answer 1 by squared 2 factorial x minus half, of course here squared, plus pi to the power 4 over 4 factorial x minus half to the power 4. So here the question said non-zero terms, and this is non-zero terms. So we'll stop at these terms. So now we need to find the approximate value for sine pi over 2 plus pi over 10. I just need to substitute here sine pi over 2 plus pi over 10 will equals to sine. Now I will substitute here. I will take pi outside. Then 1 over 2 plus 1 over 10. Then I will substitute in this function here. It will be equal 1 minus pi squared over 2 factorials. And here x will be 1 over 2 plus 1 over 10. 1 over 2 minus 1 over 2 will be deleted. So I will have here 1 over 10 squared plus pi to the power 4 factorial. And again, half will be deleted, and I will have 1 over 10 to the power 4. And this will be equal, if you use the calculator, you can find the answer 0.951. Where does x go for the first term? Here I just substitute, because I substitute here x equal to half. It is centered at 0.5. So we substitute every x with half. And now for this example, it was 10 marks. I don't remember the year, I think last year, 2 years ago. Use Newton-Raphson to calculate the volume of 1 mole of benzene at pressure P equal to 100 and then the temperature 5,000. And this obey the van der Waals equation. And the constant for particular compound A equal to 18 and B equal to 0.1193. Then we'll apply the van der Waals equation here. The question said, conduct 3 iterations to estimate the root of the above equation using an initial estimate specific volume V equal to 2 liter. So in this equation, this means you should find the root for V and then find the absolute relative approximate error. We actually solved this example in the tutorials. The main thing here in this equation, we need to apply the Newton-Raphson equation. Our guess will be equal to the initial guess minus the function at this number, at this initial guess, divided by the differentiation of this function at the same guess. And then we apply, we just make arrangement for this equation to find the differentiation. We can do like this table, and we put our results here, the initial guess, then the other guess, and we find the function, then f prime, then we find the error. You can notice the error here will go down. Actually, it is just calculation, so I didn't use my hand to actually solve it. And you can use, for this example, solver. You can use solver, and I'm sure now you are very expert in solver. So in 2017, we have these equations. I usually bring like these equations. If you look to the past exams, you'll see similar to these questions maybe in every exam. So find the critical point for fxy equal to x cubed minus 3x squared times y minus 12x squared minus the 3y squared. Determine the type of the stationary point. The first step for these equations, you should calculate fx. the differentiation, partial differentiation of this function with respect to x. And then you make this results equal to 0. So what is the differentiation of this function? 2x cubed. This means 6x squared minus, now here, y it is constant, while this one is changeable. So it is 6xy minus 12x squared, 24x minus, this is constant 0. So minus 0. Then we'll make this equal to 0 to find the stationary point. So if we make this equal to 0, I can write it in this way: 6x squared minus 6xy minus 24x equals 0. I can divide it by 6 here. I can get this equation: x squared minus xy minus 4x. This should be equal to 0. So now the second step we need to do, we need to find fy, the differentiation of this function, the partial differentiation of this function with respect to y. So again, this one here is constant, so it will be 0. So 0 minus 3x squared, because 3x squared now constant, y it is changeable. And here again, 0 minus 6y. So also we need to make it equal to 0. We can write 3x squared minus 6y equals 0. So x squared, in this case, I can divide it by 3. X squared minus 2y equal 0. And I can write it in this way: x squared equals to 2y. Then I have now two equations. This one here and the other one here with two unknown. So I can find the stationary point in this case.
Excuse me, doctor. It's negative 3x squared minus 6y.
Yes.
Yeah, negative, yeah.
Yes, correct. At the end, we'll find this number here. Now we need to substitute this function, this equation, in this equation to find the unknown numbers. And after we substitute them, we can find the stationary point 0.0, and here 2 minus 2, and minus 4, minus 8. This is a stationary point. The question asks us to determine their type. So don't forget, fx, then fy, then we make them equal to 0. We solve the function, these two equations, to find x and y. So we found here 3 points. Now we need to determine if these points are local or minimum or saddle point. So we use, to find the nature of this critical point, we should apply the second derivative test. So we need to use fx to find fxx. Again here, it is x changeable and y is constant. So 12x minus 6y, and this one here minus 24, minus 24. Now we need to find fxy. Fxy, it will be fxy, this is 0, 0 minus 6y, minus 6x. So now we need to find fyy. Fyy, this one here, we should again differentiate it with respect to y. This is 0, so it is minus 6. And now we apply this rule. We need to find we need to apply this equation, and then we find if the point is saddle point or local or minimum, or local maximum or local minimum. So now fx, I'll give you just the first one, fx, x, fy, y times here, fyy minus f squared xy. This will be equals to actually, we'll find now for 0, 0, for 0, 0. This equals to minus 24 equals 0, 0, minus 6. And this one will be minus 6. Okay, this one is less than 0. No, sorry, fx squared. Sorry, this is time. This is more than 0. Minus 24 times minus 6. This is more than 0. And this is local maximum. Now, for the other point, 2 minus 2, it will be, if we substitute again in the same equation, it will be less than 0. And this is saddle point. The final one, minus 4, minus 8, if we actually use the same idea again, the same concept, we'll get also this one, saddle point. So don't lose mark for this equation. It is easy. Just fx, fy, then apply the second derivative test. Now in 2018, we have this question for integration. The trick with this question that if you look here, the degree of level for the numerator is more than the denominator, here 3 and here 2. So this function now, or this equation is not proper. So we need to make this equation